An exciting or fascinating world of chemistry. We're looking at gases. Now, when you look at gases, the first thing we'll look at here is the amount of gas pressure. Gas pressure is equal to the amount of force in newtons all over area in meters squared. So pressure is equal to F over A, and A is equal to mN over meter squared, which is the Pascal. Remember, we deal with kilopascals as well. So if I take different amounts of altitude, you see the reason why as we go up, the atmosphere gets thinner, there's less pressure, is because there's less atmosphere above it. So let's look at a problem like the following. Calculate the pressure under a floor tile, 50.0 centimeters on a side, if the mass above the tile has a mass of 1,984.334 kilograms. So pressure is equal to F over A. F is equal to m times A using Einstein's second law of motion. And because we're dealing with gravity, gravity is the acceleration we experience. So F is equal to m times the force due to gravity is 9.8 meters per second squared. So that's 1984.334 kilograms a meter per squared. Multiply 3, we get 19,446.27 newtons. Find area, we have length times width, or for a square, it's length squared. So we're going to have 0.500 meters, since 50.0 centimeters, 100 centimeters in a meter, so that's 0.500 meters. Square that, I get 0.250 meters squared. Divide those through, I get 77,800 pascals. We want kilopascals. Divide by 1,000, get 77.8 kilopascals. So we'll do this one in class. The mass of our tile, if it exerts 721.5 kilograms of pressure over a tile of 0.25 meters on a side. All right, so we have our gas laws, Boyle's law, Charles' law, and Gay-Lussac's law. Relationship between volume and pressure is inversely proportional at the constant temperature. The relationship between volume and temperature is directly proportional at constant pressure. And the relationship between pressure and temperature is directly proportional at constant volume. We make that into a combined gas law. P1 V1 over T1 is P2 V2 over T2. So we'll do this problem in class. Determine the volume of gas at 33.60 degrees Celsius and 1.0025 atmospheres if at STP the volume is 4.9950 liters. All right. We also can incorporate Avogadro's numbers. The relationship moles and volume is directly proportional at constant temperature and pressure. We can then incorporate that to get the ideal gas equation, which is either PV equals nRT, PV mW equal MRT, or PMW equal DRT, where R is either 0.0821 liters atmospheres per mole Kelvin, or as R is 8.31 liters kilopascals per mole Kelvin. Okay, we'll do this one in class. And with that, we're done. Take care. Be good.